In this video, we are going to go over the angle congruence theorem. The segment congruence theorem was our first theorem, and this is our second theorem, so we're going to call this T2. And it says that the congruence of angles is reflexive, symmetric, and transitive. So the reflexive property says that angle A is congruent to angle A. And this is similar to the reflexive property for segments because segment AB was congruent to segment AB, and it's also similar to the reflexive property of equality because for real numbers A equals A. Next we have symmetric. Which says that if angle A is congruent to angle B, then angle B is congruent to angle A. And transitive. Which says that if angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. Let's do a formal proof for symmetric and an informal proof for the transitive. So we have for the symmetric property that if angle A is congruent to angle B, then angle B is congruent to angle A. So first we're going to start with the given. We have that angle A is congruent to angle B, and that's because it's given. Our next step, we want to convert these angles into real numbers so that we can use the symmetric property of equality. But we know that if an angle A is congruent to an angle B, then those measures of the angles are equal. So the measure of angle A equals the measure of angle B, and that's by the definition of congruent angles. Because the definition of congruent angles states that two angles that are congruent are also equal in measure. So now that those are real numbers, we can say that the measure of angle B is equal to the measure of angle A, and we can say that using the symmetric property of equality. And last but not least, we're going to take the measure of those angles and say that those angles are congruent. And that is because, again, the definition of congruent angles. Two angles that have the same measure are congruent. And we got to what we needed to prove. Given that angle A was congruent to angle B, we came to the conclusion that angle B is congruent to angle A. So we proved the symmetric property dealing with congruent angles. Now we're going to do the informal proof for transitive property. So we have, if angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. So let's write down our given. Our given says that we have that angle A is congruent to angle B, and angle B is congruent to angle C. Let's illustrate this in a picture. Here I have three angles. Angle A is congruent to angle B, and angle B is congruent to angle C. And we need to write down what we need to prove. So we need to prove that angle A is congruent to angle C. Let's go ahead and get started. We are given that angle A is congruent to angle B, and angle B is congruent to angle C. That's our given. By the definition of congruent angles, we can say that the measure of angle A is equal to the measure of angle B, because those angles are congruent, and the measure of angle B is congruent to the measure of angle C, because those angles are congruent, and that's what the definition of congruent angles explains. Using the transitive property of equality, the measure of angle A equals the measure of angle C. And remember, the transitive property of equality was saying that a real number A equals some real number B, and a real number B equals a real number C, then therefore the real number A equals the real number C. And the measure of the angles are real numbers. So using the transitive property of equality, we can say that the measure of angle A is equal to the measure of angle C. Therefore, angle A is congruent to angle C by the definition of congruent angles, meaning that the measure of these angles are equal, therefore the angles themselves are congruent. And we have proved what we set out to prove, that angle A is congruent to angle C. And that is our second theorem, that congruent angles are reflexive, symmetric, and transitive.